people, and welcome. This video is the part 2 of simplifying radical expressions. If you did not have the opportunity to watch part 1, go ahead and do so right now before watching this video, as we're going to be using some rules, some properties in this video that you need to be aware of. If you're not aware of that, go ahead and watch part 1. As always, disclaimer time, I am human, I make mistakes, I would like to learn. Let me know where the mistakes occur and we can correct them and learn from them. Alrighty, let's go ahead and jump in with the first example. Now, the first example here is going to be the cube root of 8 divided by the cube root of 8 squared. Now, here's the thing, you do have options on how to deal with this. I am thinking maybe I can use the quotient property. So let's try this. If I use the quotient property, my index is still 3. I have 8 divided by 8 squared. 8 divided by 8 squared, that's the same thing as saying 8 divided by 8 times 8. 8 times 8 gets to be crossed out. Now, you don't actually cross things out. You can see my little, just noticed I got a little mark on my finger now. We don't actually cross things out in math. We divide out. So 8 divided by 8 is 1. So now what do we have? We have the cube root of 1 over 8. Now we're going to keep doing that quotient property because I know I can rewrite this as the cube root of 1 over the cube root of 8. Now here, the cube root of 1 is simply 1. Cube root of 8 is 2. And we are simplified. Now I'm going to go ahead and introduce some steps here that we could use instead of this method. Now, this method is fantastic, the quotient property. If you use it, it's so much easier than doing it the other way. However, with more complicated problems that we're going to keep doing, these steps may help. So the steps that I'm referring to is this. Step number 1 is you're going to, let me actually but make sure that you understand which one's which. So when we're talking about like an index or a root, this is what we're talking about, is we're talking about that end. So this is your root. For the A is, well, actually, let me back up. This is root or index. You can either hear me say root, sometimes you'll hear me say index. Then the other one, this one right here, that's called the radicand. So for step number 1, whenever you see a root, a square root here, or a cube root, a fifth root, you're going to place all of the radicand in a bubble. Again, those are actually parentheses. And then you're going to put or place an exponent of 1 on it. So it doesn't matter what you actually have in your radicand. All you're doing is let's say we have the fifth root of x squared y, and this is, 6. Doesn't matter. You're going to put all of this in a bubble, and you're going to put it as an exponent of 1. Step number 2 is you're going to rewrite or convert using rational exponents. And what this means is you're going to convert to a fractional exponent. And how do you do that? Let's do a thinking bubble. So we have always m over n. So which one's m, which one's n? This is how I think about it. Here is your square root. Here's 2. Here's x. The exponent on this is 1. So we have x to the 1/2. Another way to think about it is the exponent always goes on top. So when you're converting to a fractional exponent to a rational exponent, the exponent always goes on top of the fraction. I threw in the word numerator. That's a little bit more mathy than on top. So the exponent goes on the numerator. So the index or the root is your denominator. So how would you do this? You would say 5th root of, here's your bubble, 6x squared y to the first power. So we're going to convert that to 6x squared y to the 1/5 power. You are then going to apply the properties of exponents. So I definitely encourage you either to watch a previous video where I list all of the properties, or going on Google and printing out a PDF of the properties. Just make sure you have them in front of you. There are a few properties that we're going to be using all the time. So for example, in this one here, oops, we already got rid of that. So we have 6x squared y to the 1/5 power. We're going to apply the property. So we're going to have 6 to the 1/5 power, x to the 2/5 power, and y to the 1/5 power. Here we don't really have anything to simplify. So if you can simplify here, you would. And again, it's just an example. Sometimes you're going to use a bunch of different properties, but the property that I have here didn't really do anything for us. So you're going to simplify. And step number 5, this is only happening sometimes, but sometimes you're going to have to rewrite back to a radical form. And this is where you need to just read the instructions. Typically what happens when I'm simplifying these, I go back and forth all the time. For example, if I need to simplify, I write these in a rational exponent form. But then if I have something that needs to be like square rooted, if I have a number to the 1/5 power, to me, that's a little bit more difficult. So I rewrite it back into the radical form. All right, let's go ahead and do some examples. That's what I promised you in this video. So let's go ahead and do them. I think this is our example number 2. We have 4n to the 4th. All of this is being cubed, and we're taking the square root of that. And again, our task is to simplify. So step number 1 is we're going to rewrite it in the form. Actually, no, that's not what it is. I'm going to take all of that and put an exponent of 1. So here's the thing, you guys. Here is an exponent of 3 already. So I can still put everything in a bubble and put an exponent of 1. That's fine. My index, it doesn't have an index. That means it's 2. It's square rooted. So how would I rewrite this as a fractional exponent? Well, everything is being raised to the 1/2 power. Now this looks really, really confusing. But if you have, again, power properties, if you have an exponent being raised to an exponent, you just multiply it. So here's my exponent being raised to an exponent. So what I really have is 3/2. So I have my 4n to the 4th power, 3/2. And again, I have an exponent being raised to an exponent. So we're going to multiply those. However, we do have a different power property that we have because this is 4 times n to the 4th power, and both of the 4 and the n to the 4th power are being raised to this 3/2. So we're going to use the property and say 4 to the 3/2 power times n to the 4th raised to the 3/2 power. So now what do we have? I have 4 and 3/2 times, this is 12, n to the 4, that's 12 divided by 2. That means I have 4 to the 3/2 power times n to the 6th power. And then what do we have? We still have a fractional exponent here. We still have a rational exponent. So I need to take care of it. This is where I was saying when we were writing down the steps that sometimes it helps to rewrite it back. Like I have no idea what that means. Like I see it, I'm working with it, but in my mind, there's just something that doesn't click, and I need to rewrite it in order to understand what that is. Remember, the exponent is always on top. So what I have here is the square root. The index is on for the denominator, and I have 4 cubed, and that is being times by my n to the 6th power. Now, I'm not putting n to the 6th power inside here because there is no exponent that is a fraction on my n. No fractional exponent means it's already been simplified and we don't put it back in. All right, so what does this look like? This looks like 4 times 4 times 4. And I'm doing it this way because I know I'm taking the square root of it, so that I know that if I have 2 of the same number being multiplied, I can pull them out. So that means I can pull out a 4, and I have left over a square root of 4, and I still have my n to the 6th power. Now I'm doing a little mini happy dance because I know the square root of 4 is 2. Now, these are still all being multiplied. Make sure you're multiplying everything. 4 times 2 is 8, and that is n to the 6th power. So this original statement, the radical expression, is being simplified to 8 times n to the 6th power. All right, let's do another example. We have the square root of 40 x to the 4th, y to the 5th, z to the 3rd power. Don't let that scare you. The first thing you're going to do is you can rewrite this in terms of exponents. Again, you don't have to. It just ends up being sometimes easier. So let's actually do this one in 2 different ways. I'm going to show you using the product property, and then I'll show you using the exponent. So let's do product property first. For the product property, I'm going to split up every single thing. And have them be multiplying. So now I'm going to split up 40. 40 is, I'm thinking, 8 times 5. That doesn't really help me. So let's do 4 times 10. Here I'm going to split this up. I have x squared times x squared, or you can do x squared squared. Here, oh, this is a good one. I'm actually really happy I did this one. This is y to the 5th power. Again, you can use the properties of exponents here. For example, I can do 5 to the 4th power, y to the 4th power times y to the 1st power, because when we are multiplying the bases being the same, the exponents are being added. So 4 plus 1 is 5. And here we have z squared times z, because 2 plus 1 is 3. We're going to keep simplifying this. I have the square root of 4 times the square root of 10. Here I have the square root. Ooh. So how would this look like? I have the square root of x squared x squared squared. Then I have this one here, the square root of y to the fourth times the square root of y times the square root of z squared times the square root of z. Things are getting a little complicated here. The square root of 4 is 2. Square root of 10 we can't do, so that's going to stay. Square root of x squared squared, these go away, so I just have x squared. Y to the fourth power, that means I have same thing that happened here. So look at the similarities of x to the fourth and y to the fourth. I'm going to end up having y squared, and then I have times the square root of y. That doesn't simplify. Here I have z squared square rooted, so I'm just going to have 1z. And here I have the square root of z. So now we're going to kind of combine things. Again, still using the product property. Here's these are all outside of my square roots. So I have 2x squared y squared times z. Then I have these who are square rooted, and I'm going to multiply them. So I'm going to have times the square root of 10 times the square root of y times the square root of z, which then simplifies to my final answer as the square root of 10yz. And that is it, and that is our simplified answer. And we did this using the product property. Now let's do the exact same example, but now using the steps that I gave you in the beginning of the video, and then you can choose which one you feel is better for you. All right, so the example was the square root of 40x to the fourth power, y to the fifth power, z to the third power. We're going to take all of this inside, put it in a bubble, raise it to the power of 1. Make sure you indicate what your index is. Rewrite this as a fraction, exponent. Using the property for the exponents, we're going to rewrite this as 40 to the 1/2 power, x to the fourth to the 1/2 power, y to the fifth to the 1/2 power. And then you guys already multiplied this. That's okay. This is 5 times 1/2, which is 5/2. And then I have z cubed to the 1/2 power. So then I have 40 to the 1/2 power. This is x, 4 divided by 2. This is already 5/2, which I already did. This here is z to the 3/2. Now this one here, I am going to choose to rewrite back as a square root of 40 because in my head, it makes a little bit more sense. So I have the square root of, 4 times the square root of 10, which I have 2 root 10 here. This one here is just simply x squared because 4 divided by 2 is x squared. This one here is a little bit different, and then z is going to be a little bit different. So we're going to rewrite this, and we're going to split them up. So I'm going to have y, and this one I'm going to split up as 4 divided by 2, and I'm going to have my 1/2. The reason I'm doing this is because these are being multiplied, y times y. The bases are the same, therefore I add the exponent. I need to get to the fraction of 5/2. How do I get to the fraction of 5/2 when I'm adding? And we want whole numbers because whole numbers means it's simplified and it's out of the square root. 4 divided by 2 is 2. And I still have my y and 1/2 left over. We're going to do the same thing here. For z, I want, again, a whole number, so I'm going to do 2 divided by 2, but I still need to get 3 as my numerator, so I'm going to say I still have a 1/2 because 2 divided by 2, 2 halves is the same as 1. We already know that. But if we add these two fractions together, it does give me my 3/2. So z is simply z, and my 1/2 stays. So this is where you need to read the directions and see what your problem is asking you. Sometimes they want you to leave it in fractional exponent form, in the rational form. Sometimes they want it in radical form, so you need to read what the directions are saying. Now, I have to make a decision because I have a radical here and I have rational exponents here. So it's either I choose doing my answer in the radical form or I choose my answer doing in the rational form. So I'm going to choose to do radical. So I have 2 times x squared times y squared. Then all of these need to be combined. So I have 10 of y and z. Now the reason I'm not taking this 1/2 with my z and the y, because the 1/2 just represents that my exponent is 1, my index is 2. Same thing with my y, my exponent is 1, my index is 2. So here's my 10 with an exponent of 1, index of 2. So all of these are the same square rooted. They are being multiplied, so I can use the product property and combine them all on the inside. All right, beautiful people, let's do one more example. I want to do a division one with you. Let's see if I can quickly find one. Let's see if I can do one. Let's do this one. It's not the most complicated one, but that's okay. Oh, let's do this one. Again, it's not the most complicated one. I just want to show you how these would work. So let's do do 18 x to the 5th power divided by square root of 3x. And I just want to show you how this would work in the steps that I gave you in the beginning. So step number 1 is putting it in a bubble with an exponent of 1. Here's in a bubble with an exponent of 1. My index is 2 for both of these. So I have 18x to the 5th power to the 1/2 divided by 3x to the 1/2. Here again, we're using the power properties. So I have 18 and 1/2 times x to the 5/2. Here I have 3 to the 1/2 and I have x to the 1/2. Now, this is where it's pretty cool when you have these exponential properties because I can split this up. And again, multiplication because it's king. I have 18 to the 1/2 power divided by 3 to the 1/2 power. That's being multiplied by x to the 5/2 divided by x to the 1/2. So what's really cool is that I can actually subtract my exponents because the base is the same for my x's. So I can do x to the 5/2 minus my 1/2. And I can do it because the bases are the same. So then let's simplify this further. I have 18 to the 1/2 power divided by 3 to the 1/2 power. And that's equal to 5 minus 1. That is 4. So 4 divided by 2, which we can simplify to just x squared. Now, how do I deal with this one here? This one here tells me that I need to take the square root. And again, in my head, I have to rewrite these, you guys. If you don't need to rewrite this, that's fine. But in my head, I just need to rewrite this. I'm going to circle this as so I know that's part of my answer. So I have to have the square root of 18 divided by the square root of 3. Well, I can't take the square root of 3, but maybe I can rewrite 18. 18 is, what do I need to do? What do I need to do? I'm thinking 4 times 6 is 24. What other good numbers can I do? I'm thinking, what can I take the square root? Ooh, 9 times 2. So I'm going to take the square root of 9, take the square root of 2, which means I have 3 square rooted of 2 on top. I still have my root 3 on the bottom. That doesn't change. And I still have my x squared. That also doesn't change. So then, since I'm already here, I'm going to multiply, since this is being all multiplied, by x squared over 1. So this is 3x squared. Just kidding. Oh, we forgot my root 2 divided by my root 3. Now, a lot of times you don't want this denominator to have a rational exponent, and you don't want the denominator to have a square. Okay, so what you're going to do is you're going to get rid of this by multiplying. Sometimes you need to multiply by the conjugate, sometimes you need to multiply just what it is. So I'm going to multiply top and bottom. I'm going to rationalize the denominator by multiplying top and bottom by root 3. And again, the reason I'm doing this is because root 3 times root 3, that's simply 3. And here we have 3 times x squared times root 2 times root 3. And that can actually simplify further because I have my 3 top and bottom. So what is my final answer? I'm going to write it here. Final answer is x squared, using the product property here, times root 6. Again, the rationalizing of the denominator, you have to do that because you cannot have a root in your denominator. To rationalize the denominator, you get to multiply either by the conjugate, so refer back to what that means, or you get to multiply by the exact root that you have in the denominator. All right, beautiful people, thank you so much for your time. Thank you for watching, and I will see you in my next video. Bye.